Good afternoon. We're sort of wrapping up the first week of programming here at the Crin Pavilion at COP29. I'm Tim Shaw with Tourmaline, and today we're doing a bit of a deeper dive into the Emissions Testing Center program, which has been brought up in a few panels over the week as part of sort of the collaborative ecosystem and innovation space that exists in Alberta tackling methane emissions. So we've got all the participants of the Emissions Testing Center here today that will do a bit of a deeper dive into their part of the program, and then we'll go into some questions about what the program is and sort of what it's doing from a more technical perspective. So instead of me doing introductions, I'm just going to hand it over to the different speakers. We've got a few slides that we're going to go through, and then we'll sit down and do a bit of a panel. So kick it off is Tim Egan.
Thanks, Tim. Yeah, I'm Timothy Egan. I'm president and CEO of the Canadian Gas Association. And what I'm going to do is tell you a little bit about what triggered the creation of the Emission Testing Center, and then a little bit about what we hope to achieve with it. And then the other speakers are going to talk about substantively what's going on. So the Canadian Gas Association is a trade association in the natural gas industry in Canada. And we are responsible for delivering gas energy to Canadians. We deliver roughly 40% of Canada's energy end use as natural gas. The reality of the gas picture in Canada is that our production is growing and our consumption is growing. Gas is a preferred fuel by Canadian consumers, industrial, commercial, and residential. So we see an enormous opportunity for continued growth. But obviously, as we grow, we've also got to be making sure that we're acting in as responsible a way as possible environmentally. And one of the big environmental priorities we have is managing methane emissions, managing a variety of emissions, but methane emissions in particular. And what we did a number of years ago in an effort to help address emissions was decided that we wanted to have a particular focus on innovation. And we created something called the Natural Gas Innovation Fund. In the first instance, what it was a granting vehicle, which is now called our Industry Grants Program. And the granting vehicle started with just a couple of utilities, pooling some capital, and essentially hanging up a shingle saying that we were interested in new technology ideas from entrepreneurs, from academics, from others. We got an enormous amount of positive response from people with some of their ideas, and that in turn triggered a greater interest from industry. And the grant program grew to include 15 companies right across the value chain. So producers, midstream companies, and delivery utilities. After we created the grant program, it became apparent that some of these startups we were investing in, we're making grants to, and we've made grants to over 60 companies. Some of the companies we're making grants to clearly could get to the next level with effective investment. And we decided that what we should do is create an equity vehicle. So we did so. We created a ventures fund, and that fund is still in operation. We're near completion of investment from that fund. We raised $55 million, all private sector capital. And that fund takes, as I say, some of those startups to the next level. In parallel, though, because what we really want to do is ensure that there's a really robust innovation ecosystem out there, we thought that we needed to focus on what we do to commercialize some of these new technologies. And key to commercializing the technologies was looking at how valid they were. I'm going to try to advance the slide again here. So part of that validity, that's good. Part of that validity test is ensuring that those technology companies can actually look at the application of their technology in the field. Around this time, NRCan, the Natural Resources Canada, the federal department that deals with energy issues in Canada, was very interested in methane and was interested in the idea of a center of excellence around methane. And given the work that had been done with our grant program and with our equity fund and our interest in helping to commercialize technologies, we decided, driven largely by a couple of key players in Canada's natural gas production industry, Tourmaline and Perpetual, we decided that what we should try to do is approach the federal government, approach Enercan about this idea of a center of excellence, and propose to create an emission testing center. We were successful in our engagement with Enercan in creating that center, and it's currently located on a site owned by Tourmaline Oil, which is Canada's largest natural gas production company. The partners, Tourmaline, Perpetual, the University of Calgary as an academic partner, and ourselves, the Natural Gas Innovation Fund. Next slide. So initially, we had some support from Enercan. That support has come from now a couple of divisions of the Government of Canada, so Enercan and Prairies Can. We've also partnered and received support from Alberta Innovates, and most recently, we've received a significant partnership support from the Alberta government. That says $20 million in funding. In fact, we've received or are in the process of receiving $26 million in partnership funding. So that's partnership funding to the significant private sector capital that's being invested, which Tourmaline will be talking about a little bit later. Next slide. So I noted that we wanted to create this largely because we wanted to drive commercialization forward. Ultimately, what we want is for these innovative technologies, the companies that are producing them, to be successful in the market. So our focus is on ensuring that they have everything they need in order to be commercially successful. Next slide. And next slide. So there are four dimensions to this. An enhanced technology pipeline, the idea being that we are creating a full ecosystem pipeline of new technology ideas. Streamline commercialization pathways. How do we help entrepreneurs actually move their projects, their companies forward more quickly? Next slide. Accelerated market adoption and scale up. By doing the testing on site with a producer, what we're doing is we're allowing the technology to be tested in the field in a way that they wouldn't otherwise have access. And expanded industry and financial network. We're creating a database. We're engaged with the financial industry. As I noted a couple of times, we're effectively creating an ecosystem of new technology ideas that ultimately can move into the market more quickly, drive forward innovation, thereby driving down methane emissions and continuing to have a successful natural gas industry that's delivering fundamentally what's most important: affordable, reliable, and acceptable energy for Canadians and our customers around the world. And with that, I'm going to turn it over to one of our key partners, Ian Gates from the University of Calgary, to talk a little bit more about what's actually happening on the ground.
Thank you, Tim. So my name is Ian Gates. I'm a professor at the University of Calgary in the Department of Chemical and Petroleum Engineering, also Associate Vice President, Research and Innovation. And what I'll talk to you today is about the ETC, the Emission Test Center Lab, and what we're doing there with respect to accelerating technologies and de-risking technologies. Let's go to the next slide. So, the ETC lab, what it comprises is two main parts. There's a physical testing part, which is the lab part. That's the part you see on the right. And what you see on the other side is the modeling part. So we have both physical testing, where we can test equipment, do things rapidly, de-risk technologies, and assess how well they're doing. We can also do quite a bit of modeling with respect to physics-based modeling, so computational fluid dynamics, to look at plumes and other things, and also machine learning to look at concentration data and to start looking at predictive emissions modeling, etc. So let's go to the next slide. And so this is an example of physics-based modeling that we're doing. What you see there is the West Wolf Lake gas plant, and you can see the wind as it flows past that domain. And so, you start to look at how do you take data, concentration data, and invert it into flow rates. And of course, the wind is a key component of that estimation. So in these types of models, we can then start looking at wind fluctuations, uncertainty, and other things to quantify the gas rates and also bracket that uncertainty to get a prescribed amount of understanding of those flow rates. The other thing about these types of models, which is very useful, is the ability to start placing sensors. So to put in the minimum number of sensors needed to get a bracketed amount of uncertainty, becomes a useful outcome of these types of modeling. So, and here's a case study on a modeling project that we've done, which is on the flare stack. So when you start looking at methane purge rates in flare stacks, of course, we want to minimize that. And, the problem is you have air that can go inside the flare stack. So it's really about minimizing or really avoiding any oxygen going inside the flare stack. So what you see there is you see the plant, and then you see on the side the flare stack, and what's inside there is a purge reducer, which you would place inside the flare stack to reduce the purge rate of natural gas, so as to minimize the ingress of oxygen into that flare stack. Let's go to the next slide. And what you see there is we constructed a model of that. So it's a computational fluid dynamics model. And let's go to the next slide. And from that, we grid that up. This is how we solve the governing equations of flow. And so this would be flow within the atmosphere and within the flare stack itself. And then we go to the next slide where, sorry about the small font here, but we looked at a whole bunch of cases with respect to flow rates or purge rate to understand what is the ingress of oxygen into that flare stack. And so there's a whole bunch of cases run. And so the next slide is then the results of these types of analysis. And what you're seeing there in the colorful pictures at the top there, you're seeing the flow velocity structure as the wind goes by and you have the gas coming up the flare stack and the flow path lines in the bottom ones. So let's now go to the next slide. And here what you're seeing is the oxygen ingress. And so there with the purge reducer, you're seeing there's a certain amount of ingress, but it's lower than the case where you have no purge reducer. And then what you see there, these are two different purge rates. You see the higher the purge rate, what you're seeing is less ingress of oxygen into the flare stack. Now, the thing is, what's really useful about this is you can do these kinds of numerical experiments and test things, and they're physics based so that you can understand what's happening within the system without doing a whole load of experiments. It's very tough to do experiments on a flare stack, but we can now understand what's happening inside that flare stack. Could you please go to the next slide? And so then you start to think about, well, let's re-engineer this and start to build systems where in fact we can avoid ingress totally. And so here what we've done is we then took all our learnings from the flare stack flow and built this tip that would go on top of the flare stack, such that if there is any wind, what it does is it prevents any air going into the flare stack, no matter what. And if there is no wind, well, in that case, it simply flows out. You would not have ingress as a consequence of that. So with the CFD tools, what you can do is you can do the what ifs, you can test what's happening, you can then start to redesign and then start to examine how we would get around purge rate so that we can really, truly minimize those flow rates. Okay, the next slide. And from that, if you were to look on the screen's left side, what you're seeing is the new design where you have oxygen fraction, very little ingress. With the purge reducer, you see some ingress. With no purge reducer, quite a bit of ingress. So a design that's fairly simple, static, has no moving parts, and avoids oxygen ingress into the flare stack. So let's go to the next slide. So another example here is on methane modeling. So concentration modeling, this is using machine learning methods. And so you can use these methods to predict concentration data given a certain amount of training of data. And what we find is that, really it's that window of training data that you have to bear in mind within which you would then use it to predict a window of data. So the thing is, it's really the training window that is essential here. So we've done a lot of work to understand how training and testing works so that we can then predict emissions from concentration data. So let's go to the next slide. And now let's go to the physical side of the lab. So this is the side where we experiment, we build, and we adapt our labs to basically test equipment. So in here, what we have is we have a very user flexible lab where we have open space and we can build, let's say a company brings in their device, we can build around that device. We build infrastructure, a gas testing equipment, flow rate measurement, all of the things around what happens within the equipment that is to be tested. And we have a whole lot of analytical equipment to support all of this, but it's really a beautiful space where it's very flexible so you can build what is needed to test equipment as we see fit to support these young companies as they go through the ETC. Let's go to the next slide. And so we have 5 labs in total, and we have enclosed areas. So we have a greenhouse within our lab to test greenhouse gas or methane emissions. We have a garage out back where we can do ambient testing, so we can do seasonal testing and long-term testing outside, and a whole lot of controlled environments from -40 up to about +100, where we can put equipment into it and run it over a long time to understand how does it behave with respect to those temperatures. Something very safe and easy to do within our lab, so we can then evaluate equipment and then give data and feedback to those vendors, those technology vendors, so that they can understand how to improve their equipment and then move eventually from the lab to the field for further testing. Let's go to the next slide. This is an example of what we've done in the lab with kinetics automation. So this is a company that has used the lab, the ETC lab, and has used the field. And so in this, we're testing an actuator, which is based on a shape memory alloy, and it's an electric actuator versus a pneumatic one. So that is what we were testing in there. And we put it into our cold hot box, so we can go -40. With this one, we went up to +40, and we can test the response of the actuator with respect to temperature. So let's now go to the next slide. And what you see here is we put in a position command profile where we want to control that actuator. We tested it at -40, 20, and 40 degrees. And we at least do 2 replicates to make sure we see consistency in data, and it starts to give us an idea of errors. So what is a bracketing of error within the system? And so let's go to the next slide. And what you see there is you see the response to that command position, which is the second curve on top where you see a little bit of a lag. Now, where this is super useful for the company in that they can now learn how to adjust their actuators to make them faster response. So you do see this lag in the data, and that's data that can be precisely measured, and then that's used as input for better design. So this is at -43 degrees. And the next slide is at 23 degrees, and you can see that lag is there. And then the next slide at 46 degrees. So the beautiful thing about being in the lab is we can control that temperature very easily so that we can test a wide array of operating conditions for this equipment. Let's go to the next slide. So the thing is what happens in the lab is it's an environment which is very free and open to numerically model things, to see what happens in the virtual world, to use machine learning to improve things. And then the second side is a physical testing environment where we can test equipment in an incredibly flexible way, according to what the tech vendors need. And we can do it fast. So a typical setup we can get done within about a week. We then do testing for 1 to 2 weeks, whatever is needed, and then we can dismantle, do reporting, all of that within weeks after that. So a very rapid response so that companies can get feedback very quickly for improving their technologies, eventually helping them to get to the field. Okay, that's it for me. I'm going to now introduce Scott Malk of Tourmaline to continue the conversation.
Okay, thanks, Ian. That was great. Thanks for the introduction as well. So my name is Scott Volk. I'm the Director of Emissions and Innovation at Tourmaline. For people that don't know Tourmaline, Tourmaline is Canada's largest natural gas producer, and we're the host and the operator of the field portion of the NGF Emissions Testing Center. And we say emissions testing center, but we're quite focused on methane emissions. So whenever you hear emissions testing center, just think methane emissions testing center. So if we kind of take a couple steps back, if I can go forward. Oh, I already introduced Tourmaline. Okay. It's just moving on its own now. Mind taking me back to just the next slide. Perfect, right there. So if we go back to what the Methane Emissions Testing Center is all about, it's about working with a clean tech company that's working on reducing methane emissions or detecting and quantifying methane emissions. And in order to kind of get into that, I kind of want to talk about what the different sources of methane emissions are and what all the different clean tech companies are actually working on. So everyone kind of thinks, I think I actually heard a quote on the main stage talking about all that methane emissions is just tightening the pipes. It's a little bit more complicated than tightening the pipes, and there's a lot of different clean tech companies that are working on all sorts of different solutions to address all these different types of methane emissions that are available. And they're there for a variety of different reasons. Some whether that be for safety, So in this case, if you have tanks or high pressure vessels, you need the ability for them to release pressure, or else you could have a risk of the tanks over pressuring. So those are a safety kind of reason. There's things like surface casing vent flows that a lot of clean tech companies are working on solutions for. Methane solubility is kind of understated. So just like methane, or just like any solution or any air or liquid or combination, you get the situation where you would have methane being soluble into liquid. So that could be soluble into water, that could be soluble into oil, or any type of solubility. So when you change pressure or temperature, then obviously the amount of methane that was in that liquid comes out of that liquid, and that if it's not in the right place, then that can be a problematic thing. Often there's issues with gas being stranded, so there's lots of technologies that are working on making it so that the gas can be captured or moved or taken to somewhere where it's not stranded and can be more useful. There's just general mechanical limitations. That's part of the reason why you can have methane emissions. So that would be, now we're getting into the just tighten the pipes kind of concept, or that there's often the need to transport natural gas, and transporting natural gas requires some amount of compression, and some amount of compression can have seal interactions. And then for a long time, we had this need for a remote reliable energy source. So those would be kind of pneumatic devices. So in the past, you had where high pressure methane could be used to run a pneumatic controller, where it would actually take the pressure energy out of the methane as it releases it. That's going away quite a lot, but lots of technologies are that we're working with are looking on ways to focus on reducing that. And then we have chemical reactions. So chemical reactions, any chemical reaction you have can be incomplete. Lots and lots of the companies we're working with are looking at ways to improve that and make it so that chemical reactions are more complete, or if they're not more complete, that you go back into the stranded gas situation where that gas could be moved or conserved or used for something else. So next slide. So that kind of focuses on where the methane challenge is. Now there's this concept of quantification and measurement, and what technologies are looking at right now, or what we're seeing coming through the emissions testing center as technologies in the space. So quantification can kind of be done through a number of different ways. You kind of hear this concept of a source-based quantification, or a site-based quantification, or the top-down, bottom-up, and we can kind of talk about what the different technologies are in the different space. Usually any beginning path into understanding methane regulations uses an inventory and an engineered calculation in order to kind of derive the amount of methane that could be coming from vented devices. That's kind of a starting point. Now you start getting into where some technologies are starting to come in. So you start to see handheld devices. Those could be OGI cameras. They could be high velocity samplers. There's a number of different technologies we work with that are enhancing on different types of handheld devices and how they can improve emissions. Quantification and measurement and detection. You'll see fixed wing aircraft detection. So we've worked with a number of fixed wing aircraft companies. Bridger, LSI, for example, are fixed wing aircraft companies that have come to the emissions testing center to validate and confirm their technologies. Drones, we see a number of drones. So they've come to site in order to work on different ways. It's very similar to aircraft-based sensors, but usually quite localized and more pinpointed than some of the broader detection methods. Perimeter monitors, there's something that we work with a number. Cube would be a good example of a company that does perimeter monitors, and we'll see some pictures as we kind of walk through as well. They're kind of around the perimeter, and they're relying on the wind to bring the methane to the perimeter sensor, and then that perimeter sensor can use the wind direction and usually an artificial intelligence or some sort of advanced algorithm in order to say when the wind brought the methane to the sensor, this is where it likely came from, and this is likely the concentration. Point source are a little bit more specific. You usually place them right at the source of methane, and they can just measure methane as a yes, it's there, or no, it's not. Lots and lots of advancements in truck-mounted technology, and the benefits of having a device that can go around a plume or around a source of methane and things along that space. We're seeing a lot of advancements in fixed mount cameras. Originally, Kuva was one of the earlier fixed mount cameras that we tested, and then later on we tested a lot of other things like the Schlumberger camera as well, which is really interesting as well. And satellites, believe it or not, we do work with some of the satellite companies, usually on early testing. We typically can't do a release large enough for a satellite while it's in space, but we do some early testing of their sensors and help them calibrate their sensors before they get fixed onto a satellite and launched into space. Next slide. Okay, so now we'll talk about what the facilities are, and for the most part, I'm just going to show you a picture show of hopefully cool technology that's tested at the emissions testing center and how it kind of works. So I'll walk through. These are going to be the categories of sites that we'll talk about, and then we'll talk about what we do at each individual site. So West Wolf is the hub. As Tim mentioned, it's operated by Tourmaline and jointly owned by Tourmaline and Perpetual. So that is the hub of the emissions testing center. A lot of work there in real life applications. So when clean tech companies come and ask for validation, what they want and what the testing center can deliver is a real life validation that they can either take to other companies to sell their product, or to regulators to prove that their product works, or to a number of different sources. And sometimes, and we cater to what the clean tech company is looking for. If they're looking to validate a couple of claims to put on a brochure, that's fine by us. We'll work with them on a couple of claims to put on a brochure. If they're looking for a full-blown white paper to show a regulator that they have the same probability of detection as a competing technology, we will go that far and work on a full-blown white paper. And that's definitely where the UFC and Tourmaline will collaborate on having both an academic and a real life operation to do that type of work. So, and then everything in between and I guess there is one other type of testing, early testing of prototypes. We do that at our site as well. It's nice to have the lab where Ian can work on things that are pre-CSA approved type testing, and then we can also just validate prototypes at site. And often they either fail and they just want to work on the device, or we do early testing and that's just an iteration in a prototype, and those reports typically aren't as public. Now I get back on topic here. So the vent site is just a little ways away from the West Wolf site. It's specifically designed for controlled releases, and we have a specific controlled release site for technologies that really want to do a lot of work in quantification. So it's a site that doesn't have any other sources of methane that are released, and when we do a controlled release of different amounts, we can do a lot of work on quantification. Drilling and completions, we go to our drilling and completion facilities as needed for testing there as well, and we can talk about the methane slip trailer. Other activities, so we have donated essentially all of our facilities to be able to be used depending on whether we need them in order to have a test that may or may not have a suitor on the test site. And then the well site facilities, a lot of the work in the control space is happening at well site facilities. We'll go to the next slide. Okay. So this is West Wolf, and this is just a number of pictures of what the site looks like. You can see a Cuva camera, that's the big kind of box there. You can see kind of the continuous monitors just down in the middle to the left. This is a flyover image of what happens on a flyover, and what you can see from a compressor that we're doing controlled releases on. So that's from an LSI technology. On the top, you can see the manifold system we have over the tanks. We find that a lot of clean tech companies are working on tank venting and solutions for that. So with that manifold system, we're capable of doing a single tank release or a multi-tank release using a VRU or not using a VRU, and really catering to what their technology needs. Down on to the right is the flare. So we have sensors on the volumes from the flare and things like that. So Ian talked about velocity purge reducers, so we can validate those in real space in the field using that instrumentation. And on the bottom there, on the bottom right, you see our methane slip trailer. So it's a mobile lab that we can use in order to measure how much methane moves out of a chemical reaction, like that's happening in a compressor, and how much slips through. Go to the next slide. So this is a little bit of a zoom in on camera technologies. There's a couple different technologies that are here. The top right is a Schlumberger technology. And then the bottom kind of map view is what it can see from the top of the tanks. It pans across the site and can look at methane or different sources, and the little circles on that site are kind of different points that we told it to look at, and then report back if it sees any methane. So some of that, the outputs from that are kind of in the middle of the screen there. Another technology that's using a similar camera type technology would be Cuva. It operates a little bit differently. It's kind of the black and white picture kind of up to the top right. But again, it's panning across the site and looking for methane emissions, and then showing them, and we're helping them work on validating and confirming that they can actually do these tests, and that when they are quantifying that the quantifications are correct. Next slide. So now we get a little bit more into the point source detection. So some of these are going on to tanks. So you kind of see a number of different technologies up on the top right here. They're very focused at thief hatches or at places in tanks that are that are more likely to leak than others. So those are sensors that are specifically on the thief hatch. To some of them are physical, did it tip? Some of them are measuring amount of methane emissions from them with a monitor. And having cost-effective solutions to do this is an important thing for industry to have. So we've got a lot of different clean tech vendors that are working on solutions to monitor thief hatches from tanks. And then on the far right, that's a point source monitor. This one, Nevado Nano, it's pretty good at detecting just single point emissions and then goes into a live platform as well. So next slide. One of this, now we're kind of talking a little bit more about some truck mounted sensors. So there's an interesting thing about truck mounted. They're just kind of look like that. They're mounted right on a typical half-ton truck. But now that you can actually go around the plume or around the site, you can actually detect different wind directions, and you can actually quantify and detect methane in a different way than you could because you're physically moving around what could be a plume of methane. Next slide. So at the vent site, I kind of mentioned earlier that this is where we really focus on quantification. So at this site, when companies are coming, so maybe they have a sensor, they have a point source, they have a wind sensor, it could be any version of sensor, and they don't want to look at just whether they can detect, but they want to get down to whether they can detect the actual amount of quantity. This is where we do controlled releases and release different quantities of gas and different rates, and we verify whether they can find different gas at those rates. We have this site set up so that we can vent from 4 different places at once. We can do it blind to the clean tech vendor, or we can tell them where the vents are likely to come from. We can release from one single point or 4 sites or 4 points all at once and work on quantification. Next slide. There'll be this is some of the funner things because things are flying around. We've worked with a number of different technologies on aerial detection, some of them via satellite. So you can kind of see that GHG-SAT satellite is the kind of right center one, the dark image with around the Earth. So that's what our site looked like from space when we did a controlled release for them. On the far right, you see Bridger technology. That's a LiDAR-based technology that sends a laser beam down from an aircraft and comes back up again and will measure the amount of methane in the plume actually at the site. So that's a laser on the site there. Bridger, you can see the actual laser box kind of in the top left portion there as well. Lots of drone work happening at the site. Lots of people working on different types of sensors and how they work with drones. That helicopter over on the right is working with LSI in order to detect kind of a competition to Bridger and see how it does at quantifying methane and detecting methane. Next slide. With perimeter monitors, there's a lot of data. So one of the nice things about perimeter monitors is that they're continuous monitors and they're measuring every single second. One of the downsides with perimeter monitors is that they're measuring every single second. So that's a large amount of data. And what we're working a lot with them on is finding ways to triangulate from a perimeter sensor, turn what direction the wind is coming from, and then finding ways to quantify what the amount of methane emissions that would be from a single source on that site or from variable sources on that site would go back to the site. So lots of work with technologies here. This is where you see some of the more advanced artificial intelligence and data analysis systems being adopted. Next slide. So yeah, the methane emissions testing center is significantly more than just the one hub. It involves every facility that Tourmaline owns. So here's some things that we've done at other facilities, and I'll kind of walk through on the next slide on pictures. So one of the big things when it comes to mitigating methane that companies are working on are ways to mitigate methane in a compressor. So the far right is showing what a compressor looks like in an oil and gas operation. So it has a reciprocating compression on that operation. There's valves in that, and have a number of different technologies that are looking at different ways to improve compressor packing and valve systems. And we're able to bring them to the site, test and validate whether it's working and whether it is really reducing emissions. And then they can use that in order to decide to sell to market or what have you. Next slide. One of the probably most unique and probably forward-thinking parts of the emissions testing center is our mobile lab. The mobile lab is concentrated on exhaust systems. So whether it be exhaust systems from engines or boilers or anything that would be consuming natural gas, we have a mobile lab where we go around and test different types of engines to see whether there is whether there's slip from the engine, but more importantly, we're testing technology adaptations and things that improve the chemical reactions on the engines and testing whether they're working or not. You'll see a lot of Series 5 upgrades at Tourmaline, and those upgrades we've validated at the testing site as a drastic improvement on methane emissions, as well as working with all the different engine vendors and different vendors to improve slip from engines. Next slide. This is a picture of a Series 5 that's kind of showing where the methane slip would be coming from, along with some of the engines. So that's a technology that's come to the emissions testing center to be validated. It's working quite well at drastically reducing methane emissions. Next slide. Well sites are probably one of the earliest things that we looked at as far as methane emissions, and one of the bigger places where we see technology innovation. So I mentioned pneumatic controls as being a source of methane. This is one of the places where we do a lot of work on controls and a lot of work on site detection. Next slide. So here's a couple different technologies that we've tested. So Ian talked about kinetics being the shape memory alloy electric actuator. And that's one of the technologies that graduated from starting out in the lab, being validated in the lab, moving to the emissions testing center out in the field, getting a real life validation, and then having the data to go and have a commercial product that they can sell to the market. So a really good focus on how we can get technology companies to market. That's a BC company that's solving solutions for the industry right now, being British Columbia, Canada. We also do lots of work with other electric actuators and lots of other alternatives to actuators like multi-phase flow. Next slide. One alternative to methane pneumatics is to still keep the pneumatic instrumentation in place, but to replace the methane with air. So we've been validating and working with a lot of companies that are working on that type of solution. So that would be essentially compressed air as an alternative to methane in the pneumatics themselves. So they leave all the equipment on site, but create compressed air. And here's a number of companies that are working in that space that have also come to the emissions testing center. Next slide. Yeah. The other thing that can happen, or that is useful for when you have stranded gas and you have no way to get that gas to a marketplace, and the alternative is to combust it. Obviously, when you combust it, you want to do that very efficiently. We've been working with a number of different companies that are focused on ways to do that more efficiently. One being a more standard combustor that's kind of running a specialty sensors in order to have that reaction work out better. And then the one on the right is actually a plasma combustor, which is actually running the methane through a plasma in order to fully oxidize it and turn it into CO2 instead of methane, where it drastically reduces emissions. Next slide. Yeah, I'm hoping I'm coming to the end here. This is getting long. One of the last places that we look at methane emissions and how to reduce them would be on drilling and completion. So this would be I'll jump kind of right into the next slide, and we can kind of talk a little bit more on how that works. So as we're displacing diesel fuel on drilling rigs and looking at ways to run our drilling rigs on natural gas or completions on natural gas, we also have to look at ways to make sure that that gas is being consumed completely and that there aren't any methane emissions from that gas. So this is a good place where the methane slip trailer can be really helpful, working with technology companies that are focused on reducing emissions in the drilling and completion space. Next slide. Okay, that's everything. I think we'll go to the panel and have a bit of a conversation.
All right. Thanks each of you for your overviews of sort of your piece of that work and that project. And I got to say, going through the emissions testing, I don't think those presentations really do justice to how cool those facilities are, and you can really see those technologies in place. And as you walk through, I mean, going through a facility at any time is and getting a tour is always interesting, but at West Wolf Lake you can see where there's more instrumentation and sensors throughout the facility, so that data can be captured on site there, but as well transferred back so that offsite data users can use that as well. And I love going through Ian's lab and seeing what they've cobbled together to test, and all the things that they get to play with. It actually looks like a ton of fun. So okay, we'll jump into some questions here. The few minutes that we have left. Now, Tim, we'll start with you. And actually, I think, Scott, this might be something that you can fill in some of the backstory on. We talked a little bit about the ETC and why it was put together. But is there more on sort of the events that kicked this off? Like what's the backstory for it and how it all really came to be?
Well, I think the principal backstory is that uh, the natural gas industry is very keen on driving forward innovation, particularly innovation in improving environmental performance. And we recognize that, you know, they're well, the way I put it was, for decades and decades, we've talked about all the innovation in the electricity industry, and a ton of public money has been put into it. And the natural gas industry really hasn't had a light shone on it, and the innovation that's underway in that industry. And we thought, what if we were to create mechanisms to give profile to the gas industry and some of the creativity that's underway? And what more creativity could we trigger? What more innovation could we trigger? And that created the natural gas, that led to our creation of the Natural Gas Innovation Fund. But the other thing we wanted to really focus on was, it's all well and good to talk about new ideas and to encourage entrepreneurs to bring ideas forward and to throw some money at them. But moving from idea to commercial product is really, really hard. It takes a very long time. And we wanted to make sure that we were making that commercialization process as efficient, as expeditious as possible. And key to that is, I've got a new technology idea. I need to be able to test it, right? And if I can test it in the field, if I can test it at the site of a company like Tourmaline that may, through that testing process say, we want to use this technology, right? And then through the network of producers and companies right across the value chain, we can give exposure to the whole industry. What you're doing is you're helping somebody with a startup idea turn it into a commercial opportunity much more quickly than they might otherwise have a chance to do so. And so too with the partnership with the university. University labs are fundamental to driving innovation, to driving startups to market. But if we can be bringing the university together with industrial players in the field, with government partners who are interested in co-funding this, we can hopefully move the whole thing forward. So that was the impetus for the whole thing, and I think we've got a pretty unique model, and it's worked incredibly well so far.
Yeah, and I might just add to that, in that the Alberta government also did something that was really interesting, that really drove all these innovation companies into this particular space, and that was through the creation of the tier program. And there's an offset program that companies can use in order to get value for reducing methane emissions. And that sparked just a huge amount of companies that wanted to come into the space and help producers find ways to reduce methane emissions. And that drive really made us see the need to specifically focus on methane emissions and all the companies that are lined up. Like, now we're at the point where we've had 75 companies through the ETC, and we've had over 100 and some that have come to the site and are in the process of moving through. We're now at the point that we have a pretty big wait list of companies moving through. It's huge uptake, lots of good innovation coming right out of Canada, right out of Alberta.
So Scott, maybe this a bit of an extension or a build on that. So there was the tier program really provided that incentive for companies to start to get involved. When I look at the ETC, it takes resources to run for sure. Tourmaline's got people that are dedicated to it, and put a fair bit of effort into making it a success. So what is it that really pulled Tourmaline into seeing this as something that was a worthwhile investment, something to pursue?
Yeah, so Tourmaline's always been a strong supporter of NGIF. So we support all the branches of NGIF, which would be grants and ventures and the ETC. So we've always been a strong supporter there. But we also saw the need. So as regulations are becoming more and more stringent, we need more and more technology solutions. I've said many times that the challenge is getting exponentially harder as we kind of take on the easier stuff and have only the harder stuff left. And that needs a whole new set of technology beyond what we have today to get into some of the more difficult challenges. So there's definitely the need. And I guess we probably didn't know it going in, but we've built a ridiculous amount of intelligence in the space just by running the emissions testing center. So we're very aware now of every single technology that exists. We're very aware of all the pros and cons of the different types of technology, some of the limitations of those technologies, and have been able to adapt just a massive amount of methane mitigation and detection technology across Tourmaline.
So some real value being realized as that intelligence was built, as started to operate and brought more companies through and whatnot. Ian, same sort of question to you. I can't imagine you just had some spare lab space around U of C and decided you wanted to fill it with some of this stuff. What was it that drew U of C to be a participant in the project here?
I mean, universities were got young, passionate people who want to contribute, who want to invent things and find solutions to challenges. You know, the ETC is, in my view, is, you know, the ideal type of project where a university can really contribute in the sense that, you know, we have training. So we have students, HQP that are there. And, you know, and the other side of it is we have labs, we have resources that we can use for quick testing. So in many ways, what you find is that, you know, when I look at the ETC, you know, and when I was first talking to John Adams about it many years ago, you know, is exactly the types of projects that we need more at the university, where we're deeply you know, entrenched within the work of solving a challenge that industry and, you know, the public need to solve, right? Methane emissions. And so here it's completely applied. It's but with fundamental components. There's research within it. It's got training elements where students are involved with the projects. They're there in the labs helping these tech vendors to get their technology tested and verified. The other side of it is they get exposed to a sense of innovation. They actually see, you know, tech vendors struggling through the struggle of getting their technology working. And this is incredibly insightful for the students to understand, because it then provides them an understanding of the struggle they may go through if they were to do the same thing. So this focus on startups, building new technology, developing new things to answer these challenges. So in many ways, it's in my view an ideal project because it, you know, well, program because it embeds everything we want for how a university can contribute to society, industry, communities, and others. So within not just big industry, but small tech vendors, you know, it's terrifically inventive in the labs. We see things, we go, oh, how about try this? This will improve a thing. And that's a wonderful synergy to have there.
Great. And how many is there full-time university resources? Like how many people are working there? How many students have been through the program?
So it's a fairly flexible arrangement. So of course, students have their theses and they're working on their research. But the thing is, we embed them through they're like dessert projects, right? So they get involved with ETC projects as needed. And so we've now had it's over 20 students and postdocs who have been involved in various projects through the ETC over the last few years. You know, what's exciting about it is that it gives them a sense of difference in research because they can see direct impact. You know, these are short-term tests. They're not like 2-year research projects or 4-year research projects. These are short-term tests where they work directly with the companies to then help solve a challenge. So they see immediate feedback for their efforts. And that's what makes it quite exciting for them.
Yeah, great. Having that hands-on experience on developing some of those leading technologies is definitely great experience for students like that. And on that leadership, you know, these technologies are part of what make Canada a leader in the space of methane management. And you know, is this starting to be recognized outside of our borders? How, and open to whoever wants to tackle this one first, but are these technologies kind of being seen by others outside of just Alberta and Canadian industry? Are they being adopted by others in other places? Like, what's the impact of the ETC and some of these technologies and companies that have been built out of here on sort of the broader challenge of tackling methane emissions?
I can do some examples, and I'm sure people will have some follow up on it as well. So some of the examples of some of the technologies that are moving worldwide from the emissions testing center would include GHGSat. We're seeing them here. They're very big presence here. Between all forms of NGF, we were kind of with GHGSat quite early with grants, kind of helping them out to kind of get started. And we have done some testing and validation with them. I was just talking with Stefan about the next phase of what that might look like with some of their aircraft detection equipment as well. So that would be one that's a very global company. Cube, a small little company out of Calgary, has kind of come out of the blue and become a really major player in continuous emissions monitors. They've already moved down into the United States and have done a lot of exports there. In the mitigation space, for example, Converge started out as WestGen, started out here in Alberta as well, or in Alberta as well, and has a huge presence down in the U.S. working on mitigating methane emissions in the United States as well. So, yes, absolutely, there has been technologies that we've tested and validated that have gotten their start in Alberta and moved on. But there's also partnerships that we have as well. So we're working with METAC and in order to have an extension of their facility in Colorado. So if people need cold and trees and a few things that aren't really at their facility, we do collaborations with them. We do collaborations with some of the local players as well, like Carbon Management Canada. We've done collaborations with PTAC CanAir and virtually the entire ecosystem in Alberta. We've had some version, well, even Canada, SRC has done lots of work at our site as well. So we're very focused on collaboration. We kind of see methane emissions reductions as one of the places where it's kind of all hands on deck, and happy to work with everyone in order to keep reducing it.
Tim, maybe if I could just add, we hosted a global conference a couple of months ago in Canada called the International Gas Research Conference. It's held every 3 years, and it has historically been very focused on R&D in the gas industry. We broadened its focus to include both R&D and innovation. And as part of that broadening, we raised $10 million from the industry, companies like Tourmaline, a number of other producers, $10 million in grant money that we awarded in a competition process. And we made that competition open to companies around the world. And we're doing that again this year, $5 million this year. We hope to continue. It was a special project because of the International Gas Research Conference, but the next $5 million will be awarded in 2025. But the idea here is to take the approach we're taking with NGIF to the world, and let the world know that Canada's natural gas industry, which is already supplying energy to the world in a variety of ways and wants to be supplying a lot more to the world, is also very interested in supporting the technologies that will help improve the environmental performance of that industry worldwide. And we're very keen on deepening the conversation with government about what this opportunity represents, because so often, Scott made reference to the regulatory framework and some of the targets and some of the challenges around that we have as an industry. Very often, the focus of government is on saying to our own industry, we want you to be better, which is terrific, but it's almost done in isolation of what's happening around the world. And the performance of Canada's industry is extraordinary. And we want to be making sure that that performance is seen by the world, because we think we could actually be delivering significant reductions in methane emissions around the world, much more significant in terms of actual volume of reduction than is happening in Canada. And we want to realize that opportunity because it will both deliver economic benefits for Canada, but also address a global challenge with methane emissions.
Yeah, great. And IGRC was a great conference, and bringing the innovation stream into there was a great expansion for sure. Now so we're tackling the methane challenge head on. ETC is addressing it. We're innovating to tackle that. Are there other technologies being looked at the ETC that are related to natural gas and industry, but maybe not just on methane kind of mitigation focus? Are there other types of projects that you guys have on the go within ETC?
Well, we all have lots of projects outside of the ETC that are in that space. Tourmaline, UFC, I know about all of our projects that are happening in that space, but we have kept the emissions testing center very specific to methane. It's important to our funders that it be a methane specific challenge, and it's important to our brand. And to be honest, we have so many companies coming in right now. We designed implemented all the instrumentation of the sites for methane and the controlled release sites for methane as well. So it's important to us that we kind of stay within that scope. But yeah, we're definitely delivering a lot when it comes to methane emissions reductions.
And I can add to that, definitely in the ETC lab, we're focused on methane. That's what we deal with. But you can see a lot of our practices and equipment and the infrastructure that we've built, it could be easily adapted to hydrogen. It could be easily adapted to other gases. So, you can see, that's the one key ingredient I see here in the ETC is that, an association, industry, academia working together to solve things. It really builds for a critical mass of, and especially with, deep ties to our government sponsors, it builds that critical mass for actually attacking lots of challenges that we face. Now, of course, ETC lab it's methane. That's what we do. But we're always looking, that would be great for hydrogen. That would be great for hydrogen methane mixing and things like that. So we've been looking at projects like that because it's very natural. Well, we have the equipment, we can use it for that and answer another challenge of another industry.
Yeah. Sorry. Yeah. The technologies that we're testing, although they're relatively specific to the oil and gas sector and to methane specifically, that is a good note that they're applied to a lot of different things as they're developed in this sector. So we've seen continuous monitors be moved into spaces like waste and landfills and things like that. We've seen our continuous monitors be moved into cattle and livestock production. We've seen the aircraft that we've been developing being moved into other sectors. And like we have seen these be the groundwork of starting from methane, but growing into other pieces. You heard GHG-SAT started out in methane and now they have a CO2 sensor. We've seen the same with Cube where they started out in methane and now they also have a CO2 sensor. So yeah, there's definitely a lot of adaptation or application of the technologies that get tested at the center and validated at the center that move into other aspects of emissions performance as well.
Yeah, the ETC is necessarily focused on methane, but it's a model for testing technology that could be applied to a host of other things we do in the gas industry in our ongoing efforts to improve our environmental performance. And NGIF is investing in a whole range of technologies in that regard. Ian made reference to hydrogen. We've looked at investments in renewable natural gas and hydrogen, so alternative fuels. We've looked at opportunities to blend those fuels. We've looked at technologies around efficiency improvements, overall efficiency improvements in the value chain, emission controls on the downstream, a range of technology opportunities. And then we could think about an ETC model being applied to those as we evolve. I mean, we're still early days in this exercise, but there's lots more we could be doing here.
Yeah, and even though it's early days, there's been some successes. So, is there a certain technology or a project or something that has gone through the ETC or happened because of your participation in the ETC that you guys can speak to, something that kind of stands out to you?
I try not to pick too many winners and losers. It's kind of like trying to pick your favorite child. If you actually pick one, it'll never turn out well. So when usually I kind of use this to kind of talk about the different applications of the technologies and like things like methane mitigate or methane sensing technologies and how very different they are and how much they're needed. All these different types of technologies are needed. So satellite gives you like a world picture right all at one time. Every time the satellite goes around daily, you're getting a world picture. You have aircraft technology that can kind of go down and give you real quantification at a source level and pinpoint where the source is, and that's incredibly important. Continuous monitors are running all the time, so if there's intermittent emissions, you can kind of pick up things that flying over once with a satellite or flying over once with an aircraft you can't really get. Truck-mounted sensors that moving around the plume with the truck-mounted sensor really allows you to differentiate between different types of gas. Some that might be venting on purpose, some that might be fugitives. So there's a lot of strength in those technologies, and then having it in drones and things like that definitely give you strength. So all the technology companies that come to the testing center have like really valid testing that are really important to that industry has the solutions.
It's a very diplomatic answer. I would say that drones are pretty cool, but I don't know. Ian, something.
Yeah, no, I can't say, there's no winning or winner or loser here. I mean, they all have really interesting challenges. And I find that, what makes the ETC project so interesting is it's not standard research. It's not just about getting a single data point. You find that data acquisition and putting it into a -40, you suddenly find all kinds of issues there you'd never have seen before in a standard 21-degree lab, right? So what I find is, that constant challenge is what makes the entire thing so interesting. And every company that comes in, sometimes it's like, how are we going to do that? How are we going to build infrastructure around their device so we can test it and test it effectively and it's verifiable and that we trust the data coming out of that, our assessment of it. And it's just exciting to design things. We build infrastructure for these things, so it makes it very custom and boutique, yet widely applicable to other systems as well. So yeah, I can't pick any one that I'd say is most interesting. I mean, they've involved all kinds of apparatus, even as complicated as, gas testing equipment, all the way down to just a step ladder is the piece of apparatus around the equipment. So it's very interesting and in fact quite exciting how we work in the lab to get stuff done.
Tim, when you think about success, rather than point to a particular technology, and we could talk about a bunch of them, I'd point to results. And the results, the Alberta Minister of Energy Environment was here earlier this week and noted that Alberta's achieved a 52% reduction of methane emissions against what a 20, I can't remember the year the target, 45% target was set was.
Yeah, 45% by 2025 was the original target, and
it's been exceeded. And
exceeded.
And it's been exceeded because of, frankly, a culture of innovation in the industry, working in partnership with government, and that's the ultimate, sign of success. Is look what we can do as industry, working with academia, working with government in a cooperative fashion to drive forward to achieve. Achieve the results that everybody desires. And the thing about a culture of innovation is that it's a culture. It becomes embedded and it grows. And Ian talked about the enthusiasm of students in the lab. I can tell you, universities across the country have come forward and started talking to us because of the things we've been doing. More and more entrepreneurs are coming forward, right? And the industry as a whole is inspired by this, and I think that's the measure of success.
And I don't even know if we've mentioned this yet, but because of our great funders and because of the amount of money that the Alberta government's put in, this is a completely free service that we do, right? Like, so this is a completely free service to clean tech companies that want to come and validate their technology. We get to work with them, come to a live operating site, have the testing and the validation that you're looking for. And then because we've got such great sponsors and support from our governments in Canada, this is a free service to the companies that come and use this site.
And that includes, you don't take equity or there's no participation in the project other than supporting the testing and verification.
Yeah, no touching of IP, no equity, no anything, just completely free service. We try to move as fast as we can to accelerate technology into the market and do it with as little burden as possible. It's all about getting the solutions we need as fast as we can in order to address this challenge.
Great. So Tim touched a bit on successes, how this program word is starting to get out about the model, and companies are hearing about it and starting to get more interested in participation. There's a wait list now to get into it. And it's, we've made a ton of progress on hitting targets and surpassing targets. That progress is going to continue day after day. We'll keep building on that. So what's next for the ETC? And maybe we can wrap up with, looking forward, what are you guys going to do next with ETC? What are the next big steps? How is it going to continue to contribute to tackling methane emissions and building on those ambitions that we have? We'll start with Scott and we'll just work our way down.
Sure. So what's next from the field operations of the ETC? I would say is to really keep it going. So we've got a large list of companies that are, I wouldn't even necessarily call them on the wait list because they're interacting with us and they're getting their technologies ready and things like that as well. So that is definitely something that we're looking at. So that's what's next, and just keep the momentum up, keep all the clean tech companies coming through, and keep on working on validation.
So yeah, no, it's a continuation, and it's also an evolution in that, you know, we're now getting better at supporting companies. So certainly we've become much more efficient in the intake and the outcomes from the ETC lab, and you know, and also the interaction. I see we're going to have growing, you know, and it's already been happening, but growing, you know, examination of field data. You know, so we've traditionally not really, you know, done much in the field, but now lab working with folks in the field with their data to understand. So I can see that as growing in the future. But I think really it's about continuing this path that we're on. We've got a long wait list to get through. And it's really about acceleration, right? That's what we're about. How do we do it faster, better, more efficiently with less effort, but get the same quality result out?
We're at a COP event that's focused on climate finance. Oh, think about ETC in that context, and I'd say what's next is how do we demonstrate what we're doing as something that could be taken to the world, a partnership that's delivering incredible results, using dollars really efficiently, driving entrepreneurs forward, and advancing on our environmental goals in a responsible way.
Great. And I saw that we did have a question from the audience.
Yes, my name is Dunya. I'm a HSC manager of a university, Koya University. It's a university in Iraq. And actually, I have MSc in chemical engineering. I'm a educational reactor design teacher. And at Koya University, we have a project. It's named Green University. And this is the only university that have this initiative in our area, in our region. So we are the only one who suggests this, and we are a public university. Is there any chance of collaboration between like making MOU with your university, or testing or have training to test emissions inside our university? And our university have a very nice area and landscape, and we try to make it cleaner. We suggested 9 pillars for that, like building a solar system on our dormitory, changing from fossil fuel, using fossil fuel to solar systems. This is one of, and we have green research park also. So we have many ideas about that, but actually we don't have like any support or fund because our ministry, they support us like in managing and those stuff, but we are open to do this collaboration with others. Is there any chance for that with us?
Yeah, the University of Calgary is very deliberately focused on international collaborations. So certainly the way to start that is send me a note, an email, and we can chat about it. But you know, international collaboration and seeing challenges that you know, people face globally, you know, it's part of our mission to tackle those challenges. You know, and I'm sure in Iraq you also have methane emissions issues, right?
Yeah, of course, because we are petroleum.
Of course, that's right. So
Okay.
I would see that, you know, there might be potential solutions from ETC companies, the companies that come through our program, where there are opportunities for them to work in Iraq to
Yes,
help.
like for example, now if I want to have PhD, I'm thinking about collecting this data,
Mm.
but I don't know how to start because I'm too much young for that, and I don't know where to start. But if there's some collaboration, and
Well, let's have a talk after this.
yeah,
Absolutely.
of course. And today at 5 o'clock, we have our university president is here. He has a presentation about this project in our university. And I think it is very interesting if you join us.
Thank you.
Thank you.
Great. Yeah, thanks for that question, and thanks for the invite. Appreciate it. Good. Well, maybe I'll just put it out there. Are there any other questions from the audience? No. Good. Okay. Well, guys, thanks for your time today on the panel. I appreciate the bit of a deeper dive. I know we've talked about the Emissions Testing Center and the role it plays in the broader ecosystem and unlocking that innovation in Alberta. So appreciate the opportunity to get a bit deeper into some of the, what was behind it, why it started, and the work that you and your teams do into helping those tech companies really discover what's going to work best for their technologies and how it's going to best apply to industry where the opportunity to commercialize is going to come from. So thanks for that overview, and yeah, we'll hopefully be talking more about ETC and future phases and international collaborations next year. Great. Thank
Thank you.